All right, so welcome back this afternoon. I hope you had a great lunch. Sorry to wake you up. It's my great pleasure to introduce today's keynote speaker. I'm not sure actually François-René Rideau, aka Fari, needs any kind of introduction. You probably all know him. He's been an important contributor to the Common Lisp community in particular. He took over the maintenance of ASDF at some point. He's also a great traitor to the Common Lisp cause because he dropped the language and ASDF in order to move to gerbil scheme. But we still do love him, right? Right? So we do, as a proof of love, we had him as the program chair last year, and we have him this time as a keynote speaker, but that's not actually the reason why we do love him. There are two reasons. The first one is he's French. And the second one is shoes accepted, he is a true fashion statement. So you have the floor with your shoes.
Today I'm going to tell you about the past and the future of Lisp. And let's start with the part. Who knows who are the people on this picture and what they are doing? Yes?
Stuart Russell.
No, almost.
Almost.
It would be Steve Russell, but it's not him.
Someone who...
Dan Edwards to the left. And Peter Sampson in the middle. And to the right, we have a PDP-1 playing Space War, the first and at the time only video game. And it was indeed written by Steve Russell, who is also the guy who wrote the first Lisp implementation. And to the left, we have Dan Edwards, who was the garbage collector of Lisp, the first garbage collector. And in the middle, we have Peter Sampson, who would write PDP-1 Lisp, which is... Peter Sampson, who would write PDP-1 Lisp, which was the first interactive language ever, maybe. At least first interactive Lisp for sure, and maybe programming language implementation. Okay, and they both contributed also to Space War, adding things like gravity and whatever else. Okay, Lambda the ultimate. Who knows who these guys are? Yes?
Tom Knight and Greenblatt.
Yes, yes. Tom Knight to the left and Richard Greenblatt to the right, who are building the first Lisp machine. And Greenblatt is also the guy who did MacLisp. So, let's start the talk itself by a cone. A student, in hopes of understanding the Lambda nature, came to Greenblatt. As they spoke, a Multics system hacker walked by. Is it true, asked the student, that PL1 has many of the same data types as Lisp? Almost before the student had finished his question, Greenblatt shouted, "Phoo!" and hit the student with a stick. Years before he built the connection machine, Danny Hillis composed this and other koans. Instead of Buddhist Zen masters and their disciples, these koans featured Lisp hackers from the MIT AI lab, and thus Danny Hillis launched a genre dispensing wisdom about modern computing in forms inherited by the ancients. About the same time, Sussman and Steele wrote their famous series of papers, Lambda, the ultimate imperative. Lambda, the ultimate declarative. Lambda, the ultimate go-to. They launched another genre, showing how to reduce programming paradigms down to lambdas. Then the question is, so what is this lambda that imbues some software with its blessed lambda nature? What is this lambda that gives Lisp its ultimate power? Is it functional programming? Many people think it's functional programming. The Lisp hackers back then might have thought it was functional programming. It's Lambda, it's in the name. It doesn't just rhyme with Buddha, it's the essence of computing, is it? Well, no. These days, not just ML and Haskell, but even Python and JavaScript, and even C++ and Java, they all have lambdas, or another form of first-class anomalous function. Do they possess the lambda nature? Does C++ possess a lambda nature? Does C++ possess a lambda nature? No, no, absolutely not. And if the lambda nature is not about functional programming, how can Lisp itself have, if lambda nature is about functional programming, then how can Lisp itself have claimed to possess this lambda nature when it didn't actually have true lambdas until 1975, like 17 years after it was invented? So, whoops, this is the wrong. Oh no, this is sorry. Yes, this is the correct one. So yes, you can reduce all computations to lambdas, and that's remarkable. And lambdas are elegant. You can compose them. They are also logically simple. That's one of the simplest things. It's equivalent to functional implication. So, beautiful way to reduce computation. Beautiful thing to reduce computations to. But you could reduce computations to Turing machines. This is a finite implementation of a Turing machine, or a Turing machine with finite amount of ink and finite amount of tape. But otherwise, it's Turing machine. You could also reduce all computations to machine code, and that's actually a very useful thing to do, and people do it all the time. And it's problem with machine code, of course, it changes from machine to machine, and machines get old very quick, especially back at the time. But all that means is that lambdas and Turing machines and machine code are universal. And it's very important for a language, for a general purpose language, to have a universal subset, but it's also a basic requirement for a general purpose language. I suppose that's what makes a language general purpose, that it has a universal subset. And so that doesn't make Lisp special or any language special, it just means general purpose. So is a lambda nature just being a general purpose language? Well, there's a saying that when a wise man points to the moon, the fool looks at the finger. And the lambdas are like the moon. It's beautiful. But the magic was in the pointing all alone, and not in the lambdas themselves. When any fool can point at the moon, the wise man marvels at the finger. Well, this tool that allows anyone to point at any semantics and make the thing happen. That's much more important than whether it's a lambda or a machine code or anything else. It's ability to transform code from one form to the other. The finger. The wise man looks at the finger, not at the moon. So does Lisp have the lambda nature? Well, let's see if it does. Was this great? Okay. In the 50s, they invented artificial intelligence. Like, they anticipated it. Didn't make it happen for a while, but still, they advanced it more than anything else. Conditional expressions. Who doesn't have conditional expressions as a basic thing in a language? It didn't exist before Lisp. Meta-circular interpreters. Interpreter the semantics of your language in your language itself. And we'll see how important that is. Recursion. Recursion was a mathematical tool. You could use it to reason about programs, but it was certainly not part of any programming language before Lisp put that in. And many other things. I don't have time to discuss all that. Great advancements by Lisp. In the 60s, well, the garbage collection, macros, the REPL, it was called redevelopment cycle at the time. Error handling as part of your language, and plenty of other things in the 60s, like Lisp advancements. In the 70s, we had object orientation. The first object-oriented paper was by Bob Rowe about Carol in Lisp. First-class continuation, lexical scoping, extensible editors, and so many things in the 70s. I can't list them all. Don't have time. In the 80s, we have CLOS, CLOS, or whatever how you don't care how you pronounce it. It's the greatest object system ever designed. By far, it's still decades ahead of what exists today, apart outside the Lisp languages. They had massively parallel programming with a connection machine. They had micro-hygiene and plenty of other things. In the 90s, we have meta-object protocols and web programming with continuations, and a few other things. In the 2000s, module systems with phase separation, okay, racket and closure things. 2010, okay, but certainly Lisp was great. More, infinite syntax with macros has been done in Rust and in TypeScript for a long time, and they are better done in Racket. But anyway, yeah, it's like it's been done many times. It's just copy. I mean, maybe a bit better, but copy. And did Lisp really invent anything new? I mean, Lisp processing, Lisp. Well, the first Lisp processing language was actually IPL, invented like in '56 by Newell and Simon. So is it just like being a copycat of everything? Like even lambdas. What is a lambda? Well, sure, Lisp was the first language with a lambda, but first he didn't invent lambda. Like the lambda calculus is Church in the 30s. He didn't even read Church. He read Kleene, who had the first order logic presentation of lambda calculus, and he got it wrong. He didn't even implement lambdas properly. He failed to capture the environment, and so he invented by mistake a dynamic binding instead of lexical scoping. So he got it wrong. Is that not only he copied, but yeah, well, anyway. And then the Lispers, when they noticed that, they had to invent something that had a function spatial form that would explicitly copy the entire environment, and then you do a linear search in a gigantic A list. So you could have it, but it was so expensive that you would avoid it like the plague, if you cared anything about performance, which people did at the time because machines were really slow. And so they only invented lexical binding in '75, when Sussman and Steele found Scheme, and they still didn't use it until '78, when Steele sees this about Rabbit, showed how to compile it efficiently. And by that time, Landin in '66 had published a paper about a language called ISWIM, which is the ancestor of all the modern programming, functional programming languages. It was implemented in '68 at MIT also by Arthur Evans and the BCPL team, a language with lexical scoping. Then ML is also early '70s, Sassoler early '70s. So Scheme is not even the first language with lexical scoping. And yet people equate lexical scoping with Scheme for some reason. Some good reasons too, because they popularized it. But so let's get it straight. Even though they had the word lambdas, they didn't have true lambdas for 17 years, or even 20 years if you count the time to actually adopt it. And yet, those 20 years were the most productive of Lisp. If you look at my list, there's the 50s, the late 50s to the late 70s, like 20 years, that's where everything was done. They invented object-oriented programming, rule-based programming, everything. So they did not need the true lambda to be productive and to have the lambda nature. What they did need is something different, once again. The first lambda was copied, and badly. And Lisp processing, rule-based programming, theorem provers, type systems, Lisp copied them badly. Every paradigm that's been copied badly in Lisp. And that's the point. They could copy anything badly, and they could keep hacking on it and turning it from epic failure to epic success, because the language can keep evolving, and not just from the outside by a small cast of anointed priests. No, any regular user of Lisp can change the language and evolve the language and define macros, etc. If you are not a Lisper, you have to invent a new programming language from scratch, even anytime you have a programming language idea. And then, while you're a lone programmer or small team of programmer, you only have the time to implement one paradigm. And usually you also do it badly. Most people do it badly, and some people are good, they do it well, or they have the tenacity to keep at it and do it well, but they only have the time to do it once. And the language evolution is left in the small class of language implementers, and regular users, they have to watch for the sidelines. They can publish a bug report, but if it's not in the priority of the language implementer, it will never happen. In Lisp, you can quickly absorb any program paradigm invented by anyone else. And sure, you can do it badly, and you can also do it well, and you can keep hacking and refining it until it's not bad anymore, until it's so great that, and not just that, and it's great by itself, and it integrates with all these other paradigms that you have also imported in Lisp. And that's something you cannot do in other languages. So Lisp makes paradigms friends. And of course, the obvious example is functional programming and object-oriented programming, which for some reason in the 90s everyone knows are opposite to each other. Well, back in the 70s, Lisp had them both. And Lispers wrote these two very nice mottos. And then sure, Bob Rowe did not invent object-oriented programming. He published the first paper with that word in the correct meaning. The word was used with various bullshit meanings before. Alan Kay invented the word, but he didn't have a precise meaning to give to it. So, sure, it co-invented. But so Bob Rowe did contribute a lot. He took something, maybe pieces that exist, but he did something totally new, and he kept improving it. Every time someone had a new idea about object-oriented programming, Bob Rowe could integrate it in his systems, and in the end, he produced CLOS, once again, the best by far. And so he didn't do it alone, and that's the point. He didn't have to do it alone. He could take random ideas from random people, method combinations, and multiple inheritance done right were done by Howard Cannon, a nobody from MIT, and he could do it and revolutionize object-oriented programming, never being much recognized for it. But it was a nobody who did it, and then the idea was kept and integrated to Lisp. The power of Lisp in other languages never happened because the priest never did it. Lisp had all the paradigms, then or now popular or unpopular, deservedly or undeservedly, functional, object-oriented, rule-based, actors, declarative, imperative, logic, graphical, what have you. It has all these paradigms long before any bigoted imbecile invented any opposition between some of them, such as functional programming and object-oriented programming. The only real opposition that exists is not between the paradigm itself, it's between the fact that your resources are limited, and therefore you can only do one paradigm or the other, because you don't have Lisp and you can't combine them incrementally. So the opposition is actually, it's not an opposition between the paradigms, it's a limitation of people who don't have Lisp. So next, the serendipity of parties. Let's go back memory lane. Well, Lisp at the beginning had all something like called MX. It's some kind of infix syntax, like foo equals cons of bar foo. That's how it was written in the beginning. And it looks like any regular infix syntax, except they never fully formalized it. You'll never find a consistent use of this MX or meta expressions. The first implementation, so there was a meta-circular interpreter written by McCarthy, which was a kind of a fun thing, like look, Turing did something like that, we can do it same. Yeah, we can do a Turing kind of fun experiment, thought experiment. And then a student called Steve Russell said, you know what, it's not just a fun thing, this is an actual implementation. We are going to implement it, and it just works, and run with it, and that became the first Lisp interpreter. And the thing is that his program took data as input, and the data was written with this syntax with parentheses. And they used a lot of the original syntax had commas, but commas were painful to write and support or whatever. He preferred putting spaces. So that's how we got the sex syntax, was just a syntax designed for data, but now it was used for programs too, because it didn't have the space on these machines to implement both syntaxes, and the MX were not formalized anyway. So in '63, Tim Hart, who was maintainer of Lisp 1.5, invented something called macros. And here's what the very first macro looks like. The stash macro, which is kind of push with the arguments in the other side. And here it's what it looks like, including all the bugs in the first report on macros. You can read the slide and find the bug later. Here is PDP-6 in '66 by, is it Peter Sampson? Maybe it's Peter Sampson. Oh yeah, I was confused. PDP-1 was L. Peter Deutsch, and Peter Sampson's PDP-6. So he's the first one who decided, instead of having these magic forms at the beginning where macro, you see, you have a command and then you have the arguments. It's just like a batch processor in any command processor, except that your arguments are structured. Ooh. But it's still constants, and you read the name of a constant, the macro, you need a constant argument, and you evaluate it. It was called eval quote. And Peter Sampson said, why would we just use eval also for the top-level things? So now there's no difference between the top-level forms and the regular expressions. And so the saying that Lisp knows the value of everything, that comes after that. Before that, it was not true. The top-level forms were different. The thing you typed were different. So, and he could do that because Peter Deutsch had made Lisp interactive. So now it makes sense. There's an evolution. Like first you have this theoretical thing, then it becomes practical with batch processors, then it becomes interactive. And after things become interactive like that, people only think in terms of parents because you think as you type, and then you don't have time to think in terms of MX and then translate to SEXP. It's directly think in terms of SEXP. And see, quotes then is still full letters. '69, Greenblatt writes MacLisp. Now you have deafen. Deafen experience, it's '69. And quotes is a quote character. This is '79, Lisp machine list. Now you have def macro, '79, like 20 years later. It looks very much like you have in Common Lisp these days, and you even have back quotes. Ooh. And lowercase. It's not Lisp, L-I-S-P, uppercase, all caps. Now it's Lisp, big L, small I-S-P. Ooh. This is Common Lisp, the language, because now we have a notion of places, which you can set it or read from it. And if you don't want to, if you want your place to be computed, but you don't want to compute it twice because of the side effects, there are some slight complications. In '91, you rename getSetF method into getSetF expansion because method needs something else because now we have a built-in object system. And of course, very different approach. The schemers, they don't have a notion of place, or they don't care that much about side effects, just don't do them. So they have this version that's simpler and hygienic. Okay, so what we did see through all these things is that the language evolved and evolved a lot and took more than 20 years to go from the invention to something that resembles what we have now. And even 30 years to actually have what we have now. It hasn't evolved much since. So what did we do? Why did it work? Well, I have glitch of display glitch. Ugh. That's okay. So McCarthy, like Alan Turing, dreamt of inventing thinking machines. What he discovered instead is a machine for thinking. A language design that minimizes the overhead to express new ideas. Your ideas can be incremental and interactive extensions of existing ones. Your ideas can be cheaply refined into better ideas. The language minimizes drudgery. Wait, let me read that on a different terminal. This is not working. No, that's don't buy an ARM laptop unless you want protection against a malware, because the malware expected Intel laptop. True story, don't ask me how I know. You want a language, he discovered a language that minimizes drudgery. No more building parsers and runtimes, no more expanding design patterns by hand, no more dealing with boilerplates. The programmers can focus on the semantics of their systems, and they can go straight to the notions that matter. This is what made Lisp a great substrate for innovation and development. Its meta capabilities. Reflection, macros, embedded domain-specific languages, etc. A low barrier to entry for new ideas that you can easily copy from any other language, as well as grow in-house. T.S. Eliot wrote that immature poets imitate, mature poets steal. Lisp enables mature software poetry. Sorry. Dun-dun. So what happened then? So why did all this progress stop? You remember my slides, like 50, 60, 70 is great, 80 is still pretty good, and then it stops sometime between the late 80s and the mid-90s. What happened? Does that mean Lisp hasn't changed for the worse, at least? It has improved. If you try to use Lisp from 1994, you'll be very disappointed. So it has improved. And yet, despite this improving, the output and the creation like almost disappeared or slowed down, certainly, and the relevance of Lisp certainly thinned. So does that mean that Lisp does not have the Lambda nature anymore, or does it still have it? And yeah, what happened? There must have been other factors at stake than this meta ability. Factors that were present then. Okay. Factors that were present then and that have disappeared. So what is it? I previously likened the power of Lisp as that of being able to point a finger at semantics you're interested in. And pointing a finger is something you do for a spectator. And one of the spectators is a machine that will evaluate the semantics. But other spectators, just as importantly, are the humans who will understand enough of the semantics to keep developing the software based on it. This is a map of the ARPANET in 1973 at the height of Lisp development. And you see that MIT is there, and BBN, and Stanford, and something, I don't know where is Xerox. So all the big players in Lisp are there, and other players in Lisp. Like these people were connected. They were at MIT, Stanford, BBN, Park, which are elite, well-endowed institutions, interconnected and lavishly funded by DARPA. They gathered a critical mass of exceptionally talented researchers. So this is what we call a symathesis, or at least what Nora Bateson calls them symathesis. Given long time horizon, access to the best computer hardware available, and superior electronics communication channels, they formed a symathesis, which is a group of people who learn together, a living, mutually reinforcing culture where people discover new things and learn from each other and break new grounds, and grounds that the mainstream computing would not reach for decades. And then what happened? Well, by 1987, these machines that were a luxury were losing ground to much cheaper Unix workstations, which like for 1/10 of the price, you could have a machine that was faster and had a bit less memory, but you could still pay more to have the memory. At the same time, the Lisp-based research programs were losing funding due to the unfulfilled promises of AI, which will never happen. Like, it's all bullshit, no? Well, it looked like that way in 1987 to the funders of DARPA, who decided to cut the funds. And what makes things worse, this is a nice keyboard, this machine keyboard. In 1991, something else happened, or 1889. Well, 89, depending. Yes, in 89, Berlin Wall fell, which means that the big enemy did not exist anymore. There was peace, no more Cold War, to reap the peace dividend who could even further slash the defense spending. So now DARPA didn't even have the funds to cut the Lisp hackers from. You could not even try to recycle your Lisp thing in something else. The Lisp talent was dispersed into an industry that had grown around the business of workstations and now mass market PCs that were catching up. And both business workstations and PCs were efficiency-first cultures, driven by short-term competition, very different from the subsidized laboratories where Lisp grew up and was discovered. Instead, we had languages like BASIC, Pascal, C, C++, or Perl that occupied the niches of development of the 1990s. Niches that advanced Lisp hackers had afforded neglecting. Who cares about machines that have less than 1 megabyte of memory, you know? But not everyone had neglected these niches. And so the only small pieces of Lisp that survived are those wherein Lispers have inspired Java or JavaScript, languages that are now still very popular and brought half of Lisp libraries with them, except those that count, of course, except the Lambda nature of Lisp. A minority of researchers and hobbyists and a few odd people in the industry, thank you, kept using one or many of the dialects of Lisp. But there was no longer an active force driving Lisp forward and driving and keeping the community together. So this disappeared. Instead, now we have a Tower of Babel of dialects of Lisp, tens of which are active. The once dominant Common Lisp standard still has a dozen active implementations, maybe one more thanks to Sano-san here. And they are different enough from each other that they don't quite interoperate, but they still interoperate to some degree. That's Common Lisp. Then there is Scheme that has more standards and implementations. But still a lot of implementations, like not because there are few implementations, just too many standards. And then there are a few application-specific dialects, such as Emacs Lisp or Auto Lisp, that survive or die with our application. There is now the practically minded Clojure that has had enduring industrial success. Any Clojurists around? Yay, thank you. And of course, Racket, in a subset of the academia, has been developing its own Symathesis, but it's not as well funded and not as elite as it used to be, and certainly doesn't gather all the Lispers. And so these Lispers, the Lisp languages, are incompatible not just with each other, but even more so with mainstream languages, and introduces an impedance mismatch and a non-negligible cost if you want to share code between Lisp and C or Java or whatever. It's doable, but it's very costly. And so the breakdown of this community of Lispers has also prevented the resurgence of any unified Symathesis around Lisp as it was in the 60s or 70s. The communities just gathered to all the winds. There's also the lone wolf curse. The fragmentation of the community is not just linguistic. It's cultural. Lisp selects for brilliant individualists. The very confidence that makes a great Lisper becomes a curse without the institutional structures that once channeled it into collaboration. Each hacker builds their own cathedral. None of them interoperate. The collective output is far less than the sum of its parts. Mark Tarver diagnosed this in an article called The Bipolar Lisp Programmer, Interesting read, whether you love it or hate it. And without the shared hallways of MIT or Park, the McCarthys, Bobros, Hewitt, Sussman, Steele, etc., don't have anyone to cross-pollinate with. They're only lone wolves. Few exceptions. Thank you. Interestingly, another phenomenon has limited the amount of cooperative experimentation open to Lispers. The Common Lisp standard has drawn a line with conformant code above the line and conformant implementations below, such that it is very easy for Lispers to experiment above the line. But what is below is a black box. You have tens of implementations to be compatible with. You cannot assume anything there. And experimentation is thus both extremely hard and totally non-portable, very high cost and low benefit. Not impossible, but much less possible and much less affordable. To a point, the increasing efficiency expectations led on compilers and the complexity of code capable of fulfilling such expectations has led to a similar line on every dialect and implementation of Lisp or any language. If you want things to go fast, it has to be complex. But Lisp still makes it so easy to extend the language from above, and it used to be easy to extend it below. You could just open your Lisp machine system and extend it. It's not possible anymore. There are too many implementations, they are too different and too complex. But there is a bright future awaiting us. Dun, dun, dun. So, are we condemned to see the Lisp sympathecy gone forever? Like this is the empty school of Athens. Is a Lambda nature all for naught? Or its serendipitous discoveries to be forever lost, a memory kept by old dodderers and eccentric loners? I will argue that the age of AI, though it was not brought by Lisp and the AIs of the 1980s, is a boon for Lisp in the 2020s. The Lambda nature of Lisp was its ability to collapse the distance between a concept and its expression. This ability holds for artificial intelligences just as well as for natural stupidities. As great as an AI may be, it will always be finite in size and limited by costs. It will always be important to save on neurons, on tokens, and whatever resources these machines have, while tackling increasingly hard problems with combinatorial explosion when handled naively. The issue of representing ideas precisely and concisely becomes an objective and reproducible matter of costs and capabilities for AIs, when the same matter was only subjective and personal for humans. Now, you can actually give a number to whether Lisp is or isn't better. So if, like me, you think that Lisp is great, you should see that as an opportunity. So, anecdotal evidence shows that a human has about the same failure rate per line of code in any programming language, but still needs an order of magnitude fewer lines of code in Lisp compared to non-Lisp language, or blob, as Paul Graham dubbed them. I conjecture that the same observation will hold for AIs, and that you can save an order of magnitude in AI costs by programming in Lisp versus blob languages. I haven't tested this hypothesis yet, but I invite you with me to test it. If you have tokens to spare, try to have them generate code in Lisp versus another language and see how much tokens it takes in one case or the other. Now, of course, there remains a problem of interoperation. Using a marginal language like your favorite Lisp dialect means that you cannot benefit from code written in other languages, whether Lisp or blob, without spending scarce resources in writing either a wrapper or a translation. But AI just vastly lowered this cost. Previously, you would need weeks of skilled work, your work, to write a wrapper or translation of existing code. Now it can be generated in a matter of hours by an existing AI. Ooh, that means that all this expensive FFI layer or rewrite layer can be made cheap. Reviews, you still need to review the code. It's still time-consuming. But now the AI, you can query it interactively to understand the code that you are reviewing. It can still be reviewed faster. And the result is not perfect, but it's still improving at rapid pace, which means that it's not a solved problem, but it's a problem that is much cheaper to solve than it used to be. And I would say that the cost of the wrappers and the translations doesn't change when you use the resulting software a lot of times. So it's an investment that can pay back. The savings grow linearly with the amount of stable code you produce. So AI does not solve the language fragmentation issues, but it makes them manageable. Just like we don't deal with units anymore, we just use computers to automate unit conversion. Diving assistance. AI can help untangle legacy code. It can help refactor it into cleaner code, document it, explain it. It can add tests and specifications and correctness proofs. And modifying a language implementation below the line, while still hard, is much easier with AI. It can help you navigate the source code you're not familiar with and generate a lot of the thing. It can generate the test, etc. So at some point, you might want to modify common Lisp to unify classes and structs as per my book, Lambda, the Ultimate Object, using my C4 linearization algorithm. And before AIs, it means that you would have to tackle the implementation of SBCL and other implementation, very costly, weeks of work. Now it can be done in hours. Or you can maybe try to add better support for lazy evaluation to your Lisp, and to do it properly, you need to hack the garbage collector. Guess what? The AI can help you do that. Tasks that were previously out of reach are now feasible. So AI is an amplifier. It can amplify your good code or your bad code. You can generate lots of unmaintainable boilerplate, or you can generate well-factored uses of macros and DSLs. I often talked about 3-comma programmer, which is a Lisp version of the 3-star programmer. Who knows what a 3-star programmer is? Okay, so a 3-star programmer is a programmer. It's not like a 3-star restaurant, which is a very good restaurant. It looks like that. But a 3-star programmer is a C programmer who writes code that has star, star, star. Which means like 3 levels of indirection. If you can follow it, one, you're good, and 2, you have lots of time to spare. And a 3-comma programmer, well, you can guess, it's a Lisp programmer who writes comma, comma, comma. So yeah, if you're a 3-comma programmer, you can handle a lot of complexity. That means you're bright, but also you're not bright enough to simplify this complexity away. AI can be a 4-comma programmer. Or you can ask it to refactor the code and make it easier to so it's amplifying good things and the bad things. So AI will give you code that is too stupid or too clever, correct or incorrect, complete or incomplete, relevant or irrelevant, simple or complex, maintainable or un. It will do the good or bad things for you. It will amplify you, but it will also enable you to be Lispers in a new thematicity. So this is, if you can you see what's on this thing? It's the same school of Athens, but now everyone is a robot. Thank you to slop generators. Well, I believe that AI code generation can enable this new age of Lisp-based cooperation in the exploration of software concepts. A rejuvenated Lisp community that innovates faster than blob languages in topics that are relevant to the world at large. But it is not automatic. It requires deliberate effort by you and me. We still must want to exchange ideas with each other, and AI may facilitate the publishing of our ideas and the finding and understanding of the ideas of others, but still we must produce the thing and use the AI to do that. So I have a prophecy and a challenge. So the John McCarthy, discoverer of Lisp, was an extreme optimist. And I do not share always his extreme optimism. But when I do, I remember that change happens not outside people, but through people. And so Lisp, or the equivalent ideas, will win. I'm convinced that it will win. Even if no one listens to us and everyone does Lisp, it will be reinvented. But yeah, if it doesn't happen to us, it will happen to someone else. But it can happen through me and through you if we do the right thing and build this new AI-assisted Lisp systematicity. So come and enjoy with me the days of innovation and cooperation through expressing programming concepts as directly as possible, through incrementally extending languages with new concepts, through absorbing any and all paradigms into Lisp, faster than others can develop them outside Lisp, with barriers lowered through AI. Thank you. And before we leave, I want, of course, to pitch my book, Lambda's Ultimate Object. I think I will talk about it tomorrow, so let's not talk too much about it. And I want to tell you something very important. That's all. Do we have time for questions?
Yes, we do. Thanks for the talk, especially the end. I'm going to make some comments more than a question.
Yes.
Because what you were saying at the end resonates a lot with me. I was fortunate enough, thank God, to get I had a decent job, so I could take some time off, and I'm using AI now to generate a Lisp system and to create a Lisp language of my own dialect that I could never have done before. Yeah. Nobody would have given me the team, nobody would give me the money. I wouldn't even have the ability in my brain to do it.
Yeah.
But I had a vision that I wanted to achieve, and I was able to achieve it. Right, and I have, to some degree, I was maybe do a lightning talk on it, but there are some problematics with it I would like to point out. There's very little benefit in me actually collaborating. It slows everything down. Unless you have a really unique idea, and let's talk about a unique idea, but sharing code, if I can move 10 times faster, at least 10 times faster than I could do before, and I have to then slow that all the way down for human processes where I go to a PR, and I wait for somebody to read the email, and I wait for them to look at it, and I wait for them to maybe decide that they might accept it. It's not going to work anymore. The timescales are too truncated. If you're moving that speed, and then you suddenly have to stop, so it's just, where's the advantage?
So yes, Lisp can, once again, AI is an amplifier. It can amplify the cursed Lisp programmer as well as it can amplify the systematicity. And it's a matter of legacy and what you want to live in this world. If you're happy with the ephemerality of code that is generated and forgotten, that's fine. And I don't want to discourage you from that. If you want to partake in the systematicity, that's fine too. And the two can coexist together, and you can partake in both. You can start with code you generate, and at some point you think, oh, this part is stable enough that I want to share it, or not. Both are fine. I'm not saying that there's not space for it. But I'm saying there is a space for Lisp systematicity that there was not even a few years back.
It gets worse than that, though. It's not like that, I mean in September. Sorry.
Please give this man the microphone, please.
Oh, sorry. We can talk after.
Okay, after one then. Next.
Okay, you talked very briefly about the AI winter.
Yes.
Is it not because there was no standardization for an ABI, maybe? Because people did not sell computers that would work with it. The Lisp machines were not ready.
Well, they were ready for a lot of things, but whatever they were ready for, they were like 10 times or more too expensive for. Like, Lisp machines had hypertext documentation systems, multiple language integration, high resolution displays, etc. before anyone else. There are useful things.
But they did not scale down. They scaled up every time.
Sorry?
They did not scale down in
Yes, they did not care
in
about
ABI and processors and
they did not care about poor
compilers
people. They were
and now we
funded.
see the compiler part coming up right now.
Okay. Next, I think. Sure. It's not a question. Next.
Yeah, so a bit philosophical vintage angle on what you're saying about you making a better language, better Lisp using AI as a leverage.
Yes.
What do you think is the point of making a better Lisp if it's increasingly being used by machines to generate?
No, the point is not necessarily making a better Lisp, is making... If you like Lisp, there's chances are that you think Lisp makes you productive because it compresses the amount of things to say for your sort. It minimizes the irrelevant. It makes you focus on the things that matter. The AI that generate code has the same issue. It can generate 1 gigabyte of boilerplate with like just 10,000 lines that hide in the middle, or it can generate just those 10,000 lines. And it will require much fewer tokens, and not just that. It means that with fewer tokens, you can keep more things in context. So you can address larger problems by writing your software in Lisp or something Lisp-like versus writing it in blob and millions and zillions of lines of boilerplate. So if you believe, like me, that Lisp is valuable, it will be also valuable for the same reasons to the AI. And then the point is not making a better Lisp, or, I mean, yes, as a side effect, but the main point is that Lisp is better and will help you write better software. This gentleman here.
I have two questions. What do you think of the statement that there is less of a corpus of Lisp software on the net than for C and JavaScript, and that therefore large language models that write code will do much poorer for Lisp than for JavaScript or C?
So I don't know if that's a good question. And indeed, they are better trained in the C than in Lisp. But you know, the Lisp syntax is pretty easy to learn.
I want to ask another question, if I may.
For users, for humans as well as for machines, the Lisp syntax is the easiest part of Lisp. And as for the semantics, well, the whole point is that you don't stay within the semantics of base Lisp, but you zoom into the semantics of your problem. So, in my experience, sure, it makes lots of mistakes writing Gerbil's code or Common Lisp, but still it's useful. It's already useful. Like I could have it generate hundreds of lines of code that are worth thousands of lines of code of other language. So is it perfect? No. Is it already useful? Yes. And will it already save you lots of tokens and make code that is much easier to review because it's much smaller? Yes. I think it's positive. Some of it is conjecture, but I think it's something if you are here, you're interested in Lisp, and you should try.
Okay, I have another question.
Okay.
Word on the street has that you transitioned from Common Lisp to Gerbil scheme.
Yes.
Can you say something on the reasons for that?
I wrote a blog post on my live journal about the detailed reasons, so I don't remember all of them, and I don't have to because I can refer to that. But one of the reasons is that I found the Lisp community not as welcoming as I wanted it to be. I mean, most people are welcoming. Everyone here, I think, is welcoming. But there were a few toxic elements that made my life harder. And also, the language is less able to evolve. Common Lisp has been the same since 1994. It's a strength in some ways. It's also a weakness in other ways. And I'm interested in those other ways to make changes under the language. And I cannot do that with Common Lisp. And so I could pick one common Lisp implementation, say SBCL, but I decided to adopt Gerbil scheme because some objective and some subjective reasons. I'm friend with Rideau, and it's a language that I can hack at all the levels. And for instance, one thing I did is this C4 like hack of the object system. I could very easily do that in Gerbil scheme because I master it. It's possible to do in common Lisp. Actually, I may or may not do it if I have copious free time. But my copious free time is cheaper now that AIs can actually do most of it for me. So we'll see. Actually, I think an exercise in my book is implement C4 for your favorite language. So, you know, maybe you read my book and you do the exercise. I don't remember the number, but implement C4 for your language, which was an exercise we totally out of totally out of left field before the invention of AI. You would not ask a reader of your book to implement something for the language. But now with AI, yeah, the AI will do most of the work, so you can. Yes, this gentleman there.
The internet has a question. The internet would like to know what Lisp projects you have worked on with current AIs that support your thesis.
Well, I have the AI proofread my book, and it doesn't only find misspellings, it actually finds logical mistakes in my code. Sometimes I did an incomplete refactoring, and it could fix it or find that, oh, you forgot the word not in this sentence, so it has a semantic model. I wrote an implementation of Lisp-style inheritance in C++. Well, I didn't. Claude did. I would never have written the C++ code, but I can review it. It also implemented C++-style stupid inheritance in Lisp. Also a project that would have taken me days spent in vain to write some stupid code that no one would use. But with AI, I can prove that it's possible and it's simple, and that the reason people don't use it is not because that's hard or impossible, but because it's stupid. So you can prove, thanks to AI, that C++ is stupid. I think that's a good use of AI. Yeah, objective proof that C++ is stupid, not subjective taste.
Yeah, just a very quick comment. I completely agree with you on the amplifying property of AI. But the interesting thing, I think, is that Lisp is also an amplifier of some kind, because the language by design being as permissive, as expressive, but at the same time as permissive as it is, it really can amplify your genius ideas, yes, or your utter pile of crap. So yes, as a musician, I think we must be extremely cautious, because amplifying the output of an amplifier, all hell can break loose. Not now.
I think they amplify things along orthogonal dimensions, and so that's fine. Yes. So I'm not worried about that. But yes, it's an interesting remark.
The name of the scheme that you two mentioned is
Gerbil scheme, cons.io, cons.io, cons.io. Yes, it doesn't work right at the moment. GitHub.com/mighty-gerbils, plural, /gerbil. Gerbil scheme. Gerbil, like
Gerbil.
Gerbil. Mighty-gerbils /gerbil. What? GitHub.com/mighty.
MIT-gerbil, that's what I'm
mighty MIGHTY dash gerbils. Good. Do I have it here?
So what happened? Any comments?
Let's talk about that later.
Let's talk about it over coffee.
Personal issues. No, it will be solved. It should have been solved today. Okay. Oh no. Tomorrow. Anyway, or later today.
Okay. Thank you.
Thank you very much, and please come join my Lisp Symposium with Gerbil scheme. It's the same as Common Lisp because the barriers are down.
Thank you, and now let's have another coffee break.